morning to one and all, and thank you, sir, for such nice introduction of mine. And I am really very happy to listen by that. I am that our audience lecture and everything. So I am really glad to receive this comment in morning that make my day very beautiful. So now we are going to discuss about effective utilization of steel industry waste in construction industry. So as per the method, whenever any waste is there, I'm keeping one picture for you. Okay, so here you can see that heap of material. That heap of material is a waste which is generated from steel industry. Here you can observe me. Here I am standing near that. So today's discussion and today's topic will be like that. I didn't take anything from Google, not even a single thing from Google. Whatever you are going to learn, this is based on my own experience, my own research, my own visit. Okay, so I am expecting that session will be very useful and helpful to you to take exactly a field problem, field application, and what exactly we are facing problem in industry and what exact solution we can give. This is the a session based on my own research work, my own experience in that regard. So maybe it will very helpful to you. So here that behind me, whatever the part you are seeing, this is the local steel industry, which is nearby Surat. That steel industry is a very big and having a very good name, very reputed name. They helped me to understand regarding the steel industry waste, how I can collect, how can I process, what exactly problem they are facing for that. So they give me so many good advantageous things, right? So here again, I am not authorized person to speak that industry name over here. But yes, I am telling that I am from Surat. So there is a one big reputed steel industry is there. And they gave me permission to work with them. So this is the behind me steel industry, and whatever heap you are seeing, this is that heap. Whatever you are seeing, that it is a look like a sand. Okay, white sand. So this is not exactly white sand, but in my very first lecture, I told and gave one small example of steel industry waste. Suppose steel industry waste is there. So in that, I just gave you concept of reduce, reuse, and recycled. At that time, I told you that reuse means any waste is there and you are using that waste. Okay. So in that case, I told you the granular material will be there. Granular material. Okay. So that granular material look like a sand. So this is the exactly waste which is collected from steel industry during iron ore process, because they have to extract iron from very depth by giving a very huge amount of heat. Okay, not like 1000 centigrade, 2000 centigrade, more than that temperature they have to give. And during that iron ore process, they means during that process some granular material is produced, and that material I told you at that time, I didn't, that number was not in mind, but this specifically that lecture is there. So whatever waste material you are seeing over here, this is a look like a sand in a granular form, and per day this is like 400 metric ton around. Okay, per day more than 400 ton metric ton waste is generated per day. Okay, these quantities sometime increase but never decrease as per the talk with industry person. So we can say that whenever, not even in India, but in whole world, there are so many steel industry. If we are talking about particularly our region, our country, so you can imagine that only one industry is having that much capacity to produce their product of steel. So because of that, that much means per day 400 metric ton around waste is produced. Okay, so there are so many industries. Okay, and many steel industry having a good name, a good repo in market, and they are having a good production. So we can assume per year how much waste generation will be there from steel industry. Okay. So this is the main way, whatever we are going to discuss today. So for that waste, we will focus on our introductory part. Okay. So here you just see that I mentioned over here cement, concrete, industries, waste, and environment. Everything is together. And around that, I put some circles and I connected them. Why I did that? Here, one plus point will be there. We will little bit discuss about research too. Okay. So whatever in faculty development program, whatever lecture we all are discussing over here, so that lecture will be helpful to enhance our knowledge in any era. Okay, right? Any era we are learning, we are studying, we are discussing, so definitely something we are getting, and that's why this is our development in that particular manner, right? So in that case we will also discuss that which type of research as an academician, as a faculty member, as an industrialist we can do, as a researcher we can do, and we can exactly do needful to the society. So that will be beneficial point of this lecture. So in that I put over here like that first point will come natural resources. Okay, how that factor will come in our introductory part. Natural resources, in that last two lecture you just came to a little aware about the concept that we know. The lecture is about the use that steel industry waste in construction industry. Okay, utilization of steel industry waste in construction industry. Whenever any waste is there in construction industry, that both the things connection will be there. So I always tell my all audience that when waste and construction industry, both the things will connect, so concrete will automatically come in picture. Why? Because in this third time I'm telling that concrete is the most widely material after the water, and we all are surrounding by concrete. Means we can say that in if daily, suppose we are consuming some oxygen daily, okay, so likewise we are consuming concrete also. This is that much important and connected part of our life, and that you can feel by your daily use. You are using your home, your office, traveling for road, your transportation. Okay, so we are from field, but we are connected with that concrete indirectly and directly. Okay. So in that case, whenever waste and concrete will come in picture, so definitely there will be a discussion of natural resources. Why? Because we know that concrete production will be there. So there are so many natural resources will become in picture to manufacture concrete ingredient, right? So and concrete production and cement production. So we can simply say that 1 ton of cement production will be there. So 1 ton of CO2 emission will be generated in environment, and this is very harmful. So CO2 emission, global warming, climate change will be there. Okay. Then whenever industry is there, so definitely they are facing some waste disposal problem, because I tell you that Earth is having a specific area. Our Earth is right, but because of development and everything, day by day, production is going on, development is going on, and because of that, waste generation is also there. So there are so many industries, so they are facing a waste disposal problem. And whatever our last point that we have to do landfilling, so people are selecting that point as a first choice, and they directly go for the landfilling. Right now, here, when we are talking about specially focusing on steel industry, then we can say that utilization of that waste we can use as a fine aggregate and coarse aggregate. Then utilization of that waste in concrete we can use as a supplementary cementitious material. Then we can check its strength, durability, and different parameter. Why? Because suppose some waste is there, we are using in a concrete in a place of fine aggregate, in a place of coarse aggregate, in place of cement, but we have to check that whatever traditional concrete we have, our home made from the traditional concrete, our road, our building, bridge, they all made from that traditional concrete. Traditional concrete means simple cement, sand, coarse aggregate, fine aggregate, any admixture as per application, water. Okay, this is the exact mixture of concrete. Okay, but whenever we are using that waste in a place of concrete, so this is not like to we have to show the people that yes, we use that waste and we did that. It is not like any show off. This is the thing. We are actually giving the solution to industry that in place of that natural resources, we can use the steel industry waste. The results found okay. So to give the exact idea about the result, we have to go for the experimental work regarding concrete. Not like I used that one tube casted strength okay, and yes, you can go through that, you can use that. That thing will not happen. Whatever thing we are implemented, we are introducing in a new manner, okay, in a new manner, then we have to give proper justification that is it suitable in all aspects. If strength is good but other parameter will not match, so they that may be fail. Means you are using in home, you are using in a building, in a road, and if that is not found suitable over there, so there isn't any use of that research, that work, that waste utilization in concrete. Okay, this is the thing, like that you are just doing to show us, to show anyone that yes, that waste we collected and we use in concrete. Okay, so this is not the right practice. To exactly make it accessible, to make it feasible, to make it usable, we have to go for some research work or some experimental work. Okay, and we have to find the research gap. Why research gap here come in picture? Because we are actually using that waste. So what will be the research gap? Till that, what researcher have did work using that? They make some prototype. Okay, so they make some statement from that research, they give some conclusion, some idea. Okay, but is it exactly applicable to any structure? Is it exactly used in any structure? Okay, so how that research gap we can fill? We can fill with exact experimental work, considering different parameter. Based on that result, we come to some conclusion and we can say that yes, that component can use over here and there. So we can say that whenever steel industry waste come in picture, means not only steel industry waste, but there are so many waste. I am generally speaking that the most effective utilization in concrete industry, construction industry, and whenever construction industry word will be there and waste utilization is there, so by default that waste is in a use with concrete production. Generally, this is the general scenario, right? And why the people are thinking to use that waste in concrete? Because again I will repeat, concrete is most widely used material in the world, and because of that there is a lot of environment problems, CO2 emission, global warming. So people are finding, means researchers are finding that we are using concrete in this tremendous way. So how can we give alternate solution by saving natural resources? Fine, so that's why there are so many ways in world, and most of the waste are used by construction industry, especially in concrete production. Yesterday I shown that chart, so I will not go with each and every line. But today our focus point will be steel slag. Okay, and the waste material, steel slag, or we can say that that steel slag GGBFS means ground granulated blast furnace slag. Okay, GGBFS, steel slag. So these all things come from steel industry. Steel industry, it is not like the utensils we are using in our home. Steel industry means the industries having a reputed industry, you know the name, that they are producing a bar, okay, steel bar, which we are using in construction. Means many of you seen that if any construction is going there, so you are little aware about that beam, column, slab, everyone, we all are using home. We all that prepared our home. Okay, so we know that beam, column, slab will be there. So we need a good quality, having a good diameter steel bar. Okay, so in market there are so many steel bar is available for construction work. So these industries are producing such type of steel product. Okay, so for that steel product, there are so many industries. There are producing means they are not producing waste, but because of their main production of steel, they have to make a bar. For that, they need some iron product. So during iron ore process, whatever waste material generated, this is like a steel slag, then GGBFS. So we are discussing on that point only. So here our pinpoint that problem due to industrial waste in a means since so many days you are attending that lecture. So there is a concept in our mind that waste disposal problem is there. Definitely that problem is there. If any person is telling that no, we are not facing waste disposal problem, so this is not a right thing. Why? Because if that people will say that we are giving our waste to that person, that vendor, they are collecting, and our waste disposal problem is solved, right? But here just you think that that person having a waste disposal problem, that's why that person have to, or that industry have to call vendors to collect their waste. Okay, that's why they ask, now if they don't have any waste disposal problem, means they no need to that dump anywhere in land, dump in dump in any sea or any land or in any like a landfilling such things. If they are not facing waste disposal problem, they are facing problem. That's why they are choosing the options like landfilling, like marine filling, or any in a water body they are dumping their waste, or maybe they are asking any vendor that collect our waste. So this is the thing. Okay, but when that waste disposal problem actually solved, do you know? We know that in our world, we are right now not talking about world, but we are talking about our country or our nearby region. So suppose waste is there, government bodies are there, government bodies are financing us, and there are so many academic good reputed institutions. They are running R&D cell, research and development cell. Okay, so if the industry is having a good collaboration of that government bodies, okay, that suppose any steel industries, they're having a good collaboration of nearby industry. I am just giving example. Don't take it as ideal. I am just giving example. Suppose I'm talking about Surat. In Surat, SVNIT is there. I did my PhD from SVNIT, so I'm aware about some process and everything. So suppose SVNIT is there. So we have central government institute near in means in our city. In Surat only, there is LNT is there, SR Steel Hazira is there. The people can catch my research work and things from my some talk. So I'm giving few names. I'm not revealing everything, but yes, I am using some names. So the picture will come in your mind that what ma'am tried to tell us in the beginning: waste collection, utilization, meat industries, like. So suppose SVNIT is there, it is a central government institute in Surat only. LNT is there, SR Steel Hazira is there. So you know these are the reputed steel manufacturing companies. SR Steel Hazira, LNT. Suppose they are, I am just giving example, okay, so don't take it ideal that in lecture, ma'am told that, so they are doing like that. Don't take that. I'm just giving example. So they are, suppose they are producing 400 metric ton waste per day. Means that industry is having a lot of huge amount of waste in that industries. So what is the exact solution? And people can say that no, we are not facing waste disposal problem when they did means they have to do like some MOU with SPNIT. Fine, central government institute is there. They will do some MOU that we are manufacturing steel from that. We are collecting that waste. Our main focus on our product our main production. And during that process, we are having that much amount of waste. If we will use that waste in landfilling, in marine, then there will be a land pollution, water pollution. Okay, so better that you collect that waste, you do some research and development that exactly how that waste can be used. Or we can say reuse, or we can say that recycled, so our waste disposal problem can be solved. If that two bodies having a MOU, whatever waste will be there, they will give to institute. In institute, there are so many master project, PhD project, some individual project which is related to practical field. Okay, these are going on in such reputed institutes. So that institute professors, that students, they can do research work on that particular waste in a different way and give different solution. Okay, why MOU is there? Every year, for every different interval, material will be come to that institute, and there are so many students, researchers, PhD students, professors, they can do research as a connecting ongoing process. Not like that I am professor, I am having a two master student, I am having a three PhD student, so that particular you just do that, do that, your project is complete. Not like that. But yes, we have MOU, we are getting that waste in a continuous way. So we have to make a chain of research that exactly we can give perfect solution to practical field. We can solve exactly waste disposal, and we can say that that manufacturing process during whatever material is coming, this is the matter of proud that we can find alternative of cement, alternative of sand, alternative for concrete manufacturing. Means we are saving natural resources. If such things can be happen with industries, reputed institute, reputed R&D cell, then waste disposal problem can be solved easily. Environmental issues is there, that we know. Solution of the problem, based use of any waste in generally in concrete. No doubt there are so many other aspects too, but whenever we are focusing for that construction industry, so we are seeing that the best use of that industrial waste in concrete. And what is the exactly benefit of industrial waste utilization in concrete? We can minimize the use of cement, which is responsible for environment pollution mainly, right? So here again question will be there. I prepared that slide as per the questionnaires experience of last two lecture, because in one lecture, one faculty member or one doctorate person asked me that why we are focusing on that plastic, and I told that one person is coming with gun and one person is coming to slap me. So I have to save myself from that gun person, not the person who is going to slap me, right? Why? Because that pain will be little bit, and that gun I will die. So in that way I answer. So here the question will not arise. So I just put the slide. Why to focus on waste utilization? Okay. And why that steel industry? So not in our India, I just put some paper cutting here, that not only in India, but if you will see the newspaper of different countries, I put two to three only. So you can understand the problem of global warming, then change in seasons, change in environment. Sometimes you feel cyclone, then heavy rain, then no rain, drought, and there are so many irregularities in environment. Okay, so we have to find alternative, that how we can solve the issue of waste utilize waste production. Yeah, whatever waste production is there, how can we do management, how can we do utilize, so at least we can save environment. Because for any development of any country, any progress, generally we are measuring by the import export, and what you are importing, what you are exporting, what is the production of your country. So based on that, there are so many industries, and every industry having some waste. Here we are talking about the steel industry. So in that way we can see that because of all the issues, not only in India but in whole world, problem is there, and that's why we are focusing on waste utilization, right? So here you can see the pictorial view. Nothing is from Google. Everything is every picture, every photo is means the snap is taken by me in my own cell phone, my camera. So there is a steel industry. Okay, steel manufacturing industry is there. So here you can see that iron ore process, that granular type material is there. So what we have to do, we can directly use in a concrete as a sand replacement. Okay, because right nowadays we know that in many rivers, sea, people are just collecting sand from that by without taking prior permission of government. It means some type of irregularities in that to collect that sand. Okay, and because of that there is a river are expanding. Okay, and flood problem is there because people are doing in a like in a huge amount they are collecting that sand from river and in a seashore. Okay, so because of that water related flood type of problem is there. Okay, so here during that steel industry iron ore process, whatever product we collect that we can use in a sand. But the thing is that whenever, as per the researcher aspect, whenever we are going to use that steel industry waste as a sand replacement in a concrete, so we have to do some partial replacement only. Partial replacement means suppose in my concrete production I have to use 100% natural sand. But if I will use 100% natural sand, then there is a problem of natural resources. So what is the solution? I am doing partial replacement, but I can't go beyond the 10% or 20% replacement. Why? Because if I will go with more than 10 to 20% replacement, then strength of concrete will be reduced. Strength of concrete will be reduced. So if home is there, structure is there, where strength is not come in picture, I have to make lightweight structure like any partition wall will be there. This is not taking any structural load. Okay, or like toilet blocks. Like in our home, in our room, we are preparing like a toilet, bathroom. So in that for a wall purpose. Okay, or you I think you just must see in that blocks like paver blocks is there, paver block. Then whenever any building is in a progress to construct, at that time you in that in a place of brick they are using a many heavy and large many heavy means many having a more dimension than uh, not some butterfly in uh, so you can see over here okay which direction we are going. Wherever we are taking anything on that will be useful in any manner. You why? Because of the you can do that. You can do some with them. You can get good funding for and by using that you can do like that. You can give a good output, suggestion, good solution. Okay, so here is the characteristic of this. You can see characteristics are you by
Madam, ma'am, it seems you have been cut off.
characteristics. That is the very connecting and very good thing, that whatever characteristic we are observing in that waste powder which we collected from steel industry, similar type of characteristic we found in cement. Fine. So based on that characteristic, we have some idea in mind that whatever characteristic have cement and whatever waste we collected and we make powder, these both the things having a similar type of characteristics. Okay, and results are like similar. So if results are like similar, characteristics are like similar, so why should we not go with that waste in a place of cement? Okay, and these characteristics, these material investigation, material characteristic experimental data make us think to use that waste in a place of cement, right? Behind that also I will tell you one very good story. Discussing that, I will tell you that story only. Here I want to tell you that their waste is there. We are using it. We are thinking to use to replace 100% cement. Means we don't want to use cement in our concrete. We have to use only that waste powder. So what we did? We did 100% replacement, 80%, 90%, 70%, 60%, 50, 40, 30, 20. Okay, means from 0 to 100% replacement we have done with a 10% interval for that waste powder. But in 100 to 60, okay, we did 10% replacement, 20%, 30%, 40%, 50%. We didn't face any difficulty. But when 60 to 100% we went, so we found difficulty to manufacture concrete, to prepare you from that concrete during testing. Okay, so we faced a lot of problem during 60 to 100% replacement. Okay, we found successful result at 50% replacement. Okay, so we will discuss on that. And while discussing on that, what problem we face, that we can, I will share with you, so you can share with other person whenever you are doing any collaborative work or you are trying to guide your student in a that way. So steel industry waste utilization in construction industry. So here I make that word very large, concrete manufacturing, because I just told you whenever waste utilization will be there, so first option will come in concrete, because it is a large amount of concrete production, and any waste we can use in a concrete manufacturing as per the application of that concrete. This is a lightweight concrete, or just like as per structural point of view, strength point of view, durability point of view. So there are so many applications. So based on that, we can use a different type of waste in concrete. So here steel industry waste is there, and that waste having a similar properties like cement. So what directly solution we give in concrete manufacturing? Okay, here I put image like cement, water, fine aggregate, coarse aggregate, and mixture. So maybe some people having a little confusion that what Madam concrete is telling, and why we are in that particular thing. So most widely used main construction material in the world, that thing will be fixed in your mind. Even you can discuss in your home too with your family members that we are using. I am from mechanical field, I am from EC, I am from computer, I am from electrical. But do you know that we are using the civil related thing in a that much tremendous way? Okay, then that concrete will be obtained by mixing cementitious material, water, aggregate in required proportion. Here you can see the ingredient of concrete and mixtures chemicals are there as per the application. And here you see the concrete cube. Okay, one concrete specimen is there. So this is the concrete what I wanted to convey. So what is effective utilization of steel industry waste when we are talking about construction industry and concrete? So answer is high performance concrete. Okay, high performance concrete. Why? Because in high performance concrete, what we expect, we need greater stiffness, long term durability, means whatever aggressive environment attack will be there, but our concrete should be sustained in front of that aggressive environment. Then reduced maintenance and repair, smaller depreciation as a fixed cost. Okay, so there are the advantage of high performance concrete. Why? Because day by day there is a development, there is advancement, and we are transforming from one grade to one upgrade. Means suppose we are telling about that in I guess Indian standard 456 2000, suppose one grade was there for some general construction work like home and that. So this is upgraded from 20. Okay, so if we want to go for another higher construction, then we have to go for M30 grade. If bridge is there, then we have to go for M40 grade. Okay, so there is some upgradation of grade for different structure day by day in Indian standards too. So now there will be a question, ma'am, what is a grade and M20, M30, M40 likewise? So this is a very clear thing. Suppose you are going to construct your home. Simple, your home is there. You are using M20 grade concrete, means minimum requirement, minimum or we can say optimum requirement to construct a residential home. We need the concrete having a strength of 20 megapascal after 28 day. Means 20, you are making one concrete, making cube from that concrete. You just make that, you just pour in water for 28 days, and after 28 days, when you measure strength of that cube in universal testing machine, that then that cube strength after 28 days will be 20 megapascal. Okay, in 30 grade after 28 days, the concrete cube strength should be 30 megapascal. So whatever grade will be there, like M20, M30, M40, M50, M60, M70, M80, M100, M100. Okay, so these are the different concrete grade. So M represent mixture 20, 30, 40, 50. That represent the strength in megapascal after 28 days. Okay. So what is the application of HPC? This is in a bridge, in high-rise building, in tunnel, in pavement, in nuclear structure. So these are the important structure. Then HPC having the advantages property. So we are using that steel industry waste in high performance concrete. So we collected steel industry waste. Fine. We are focusing on construction industry. We are talking about concrete. So what will be the exit process? So we have to go for material testing. Means whatever cement we are going. So as per Indian standard code, we have to do all the testing of material to find characteristic. Then whatever aggregate we are going to use, like fine aggregate, coarse aggregate. So for that, as per the Indian standard, we have to do all the testing, whatever physical, chemical properties of that industry waste, which we can say like a GGBFS, steel slag, or steel industry waste. So these we have to go with a BS 6699. Okay, this is a British standard code, because in India this is not in a that much practice and with not that much confidence we are using that material. My research team, my students are going to do connective research. Means my UG students, my PG students, all are doing connecting research work in that chain, so that they can give some outline, some guideline that yes, with confidence you can use that. The admixture used in this research work is the superplasticizer based on second generation polycarboxylic ether polymer developed using nanotechnology. Means there is a type of admixtures. I told you that as per the application, means what is your exact need. Some you are making concrete, so strength point of view are making, durability point of view are making, or you need a lightweight concrete, heavy dense concrete, like such type of types is there. So as per that, you have to use that admixture. But here we are using HPC, high performance concrete. So we are using polycarboxylate ether polymer admixture. Okay. And we have to also check slag index, activity index, means whatever material we take on. So maybe at different place, different industries there. So that lead property and whatever iron ore material will be there. So there is a little bit change in the material property as per percentage point of view. Okay. So some composition will be in a more quantity, some composition will be in less quantity. So we have to check slag activity index to that material can be used with cement or not. Fine, because we are not getting exact use of that waste with the cement to manufacture concrete. Then there is no use of that waste utilization for concrete production. But generally, in means I am just telling about the Indian scenario. Generally, whatever industries are there, whatever slag or whatever material we are collecting as a waste, that all the material having a similar type of properties and a quantity. Okay, maybe like 5 to 7% variation is there, and this is acceptable in our field whenever we are talking about that material property. And in foreign country the scenario is like that, people are using this material in a very tremendous way, very nicely. But there is again a question that why Indian people are not focusing on that, because we are also facing environmental issues and waste disposal problem. Fine. So as per the Indian standard, we have to go for the cement test. We have to satisfy the criteria that whatever characteristics should be there for material, it is not or not. If results found okay, then we have to go for the other material. So we have to go for other material like aggregate. So in that also we have to do some test for aggregate like specific gravity, water absorption, bulk density, elongation index, flakiness index, silt content, what is the grading zone, what is the crushing value, impact value, what is the soundness with sodium sulfate or magnesium sulfate. Such tests should be there to make validate that material is okay or not to produce a concrete. Okay, so we have to go with that testing. And whatever waste powder we collected, that material's property also required that whether we can use with the cement or not. And here the thing that you collected waste, you grinded it, after what will be the another step, that you did all the material property and everything. But first you have to make that a small cube like 50 centimeter by 50 mm by 50 mm, right? So some small cube you have to prepare to check its suitability with the cement. Okay, and after preparing that cube, you have to that paste in that compressive tasting machine. This is the compression tasting machine. In that you have to make that cube. Now again question will be there, we just prepared that small cube, so how it will justified. Okay, so this small cube justification will be there if you have OPC 53 grade cement, OPC 53 grade cement. All of you heard about that, I think. If not, then just try to listen me and try to understand that OPC 53 grade cement means that cement having a strength property after 28 days 53 megapascal. So whatever waste material we replaced with the cement, like 50% cement and 50% waste powder, then the combination of that both we are using with the sand and making small cube to check its strengthability, then that strength will be 53 megapascal after 28 days. If that will be found 53 megapascal after 28 days, if it is found okay, satisfied, then we can go for concrete. So whenever we are going for concrete, so here you can see the grade of concrete M20, 40 and 60. 24 generally our construction like residential building, homes, etc. So simply people are using M20. We also go for M40. That no doubt our what material is there. We did testing and everything. This is good for 20 means this is good for general construction. But if we are going to think for bridge or high-rise building structure, okay, then it is feasible or not. And if we are going for that high strength concrete like M60, if we are going for a high strength concrete, so this come after 60. I mean 60 is like high strength. This is for bridge and high rise structure. This is for our residential and normal structure. So we selected three grade that our material is good and feasible for all grade or not. Okay. So here you can see that CC20 means your conventional concrete, means your concrete which we made for natural resources. That C20W50 means your concrete having a 20 grade but waste with 50% replacement. CC20 is your conventional concrete of 20 grade. This is your concrete 20 grade but waste 50%. Here your concrete, conventional concrete means the material ingredient we use naturally from the means like sand, cement, aggregate, whatever we use in traditional concrete. This is your conventional concrete having a 40 grade, means strength after 28 days will be 40. And this is the 40 grade of concrete having a waste 50%, means in a place of cement we did 50% replacement. Means if we are preparing concrete and we are using like a 360, okay, 360 gram cement we are using for conventional concrete. So for another concrete, what we will do, 180 cement will be there and 180 gram that waste powder will be there. So such type of replacement is there. In M60, this is revealing like conventional concrete 60° and here 50% replacement. So this is, you can see, okay, whatever I want to convey to you, this is I mentioned over here. The cement, like the 300, why here you can see 460, 510, why? Because this is CC20, CC40, CC60, means it's a conventional concrete. So here 100% cement we use and here no waste, okay. But whenever waste with 50%, okay. So here you can see cement 150, waste 150. Here in 40 grade cement 235 and waste 235. Here in M60 cement 265 and waste 265. Whatever sand aggregate we have to use, that we mention coarse aggregate, water we mention admixture, water cement ratio, that we have to consider. Means we have to uh, do mixed design, and M20 and for M20 we can do calculation as per the Indian standard guideline is there, 12096 or 12010 or 12020. Some codes are there. So by referring the code, not exactly that, I am just remembering that three code. I am just remembering. So don't fix in mind that ma'am use that three. So that will be code. This is not like that. I was just remembering. So by using the Indian standard, we can prepare the M20. But for M40 and M60, you have to do like trial and error. Okay, trial and error, and you have to find material proportion as per your strength requirement. So we prepared concrete whatever we need as per that material data. Okay, but we just prepare concrete as per strength. So this is not the thing. our concrete should be passed through compression test, for tension test, flexural test, shear test, impact test, RCPT test, durability aspect. Why? Because my concrete, I prepared concrete and this is only good in one thing, right? Only good in one thing. But if it is not suitable for another criteria, so concrete is failed. Only one parameter is good. Simple. I am just giving example. And yes, you just take it lightly. Suppose any person is going to choose means going for marriage and selecting bride or groom. Okay, so he or she is a fair, and that's why I want to marry her or him. This is not the solution. We have to check all the qualities. We have to communicate. We have to just check everything. So in concrete, that will be not like that. My strength parameter is okay, so I can use that concrete. Okay. So we have to go with all the taste, all the characteristic of concrete, that our concrete will pass for all the taste. Then only we can use for any structure. So there are different tastes for concrete. So for that, you can see that we have to do concrete manufacturing. We have to pour in water for 28 days, and for different type of shape. Here you can see cube. Here you can see that long rectangular type of that object is there. So in that flexural taste specimen can be made. Here that block is there, so you can see that for shear specimen you can prepare specimen. Okay, so you have to specimen in round for split tensile test, for compressive test, then for that beam. So here you can observe me why I am telling that, because we have checked our concrete throughout by considering all the property, by all the parameters. So yes, with 100% confidence I can tell that for this type of mixing, for this mixed property, for this waste replacement, we have to go with all the concrete characteristics parameter, and for that you have to prepare different shape and size of specimen for different testing. Here you can see the specimen. Okay, this whatever specimen you are seeing, this is only for one grade. We are having a 3 grade, so we are having a huge and large amount of testing and specimen, and based on that, here you can see that whatever specimen we prepared, that we have to pour in water for some time duration to understand the strength. Okay, this is for impact test. This is a round disc you are seeing for impact test. Why? Because I prepared concrete. I used in a breach construction, and I prepare one parapet wall. One wall is there nearby. That sidewalk is there, and nearby some wall is there. I prepared that some accident is there. Okay, accident is there, and truck suddenly stuck with that wall. Okay, if that wall will collapse, then truck will go beyond the side, and there is a large chances of a major accident if my wall is good. Okay, and the truck will accident will be there. Truck or any vehicle is stuck with that. Means directly sudden stuck is there. Sudden impact is there, but my wall is still there. So there is a safety point of view. Okay. So what is the impact? Because of that, impact test is there by using that type of risk. Flexural means suppose any earthquake type of disaster is suddenly occur. Okay, you are sitting in your home, in your office. So whatever you are, that structure is going to collapse sudden. If it will going to collapse sudden, means there isn't any chances of your survival. Why? Because it is collapse sudden. So how you will rescue yourself? But if I am preparing that type of specimen, I am checking flexural strength. Means I am we are just achieving some deflection. Means before collapse of that slab, that beam, I am having some sign that my beam, my slab, this is going to deflect. Okay, going to deflect means we can sense that this is going to collapse, so we can rescue ourselves, right? So this is the thing and scenario. By keeping so many points in mind, we are preparing specimen and doing research work. And this is the different type of specimen we have to prepare, and we have to check in a testing machine. Not like that I prepared my work or I have to just do. It is not like that. You have to do work with your experts. If they will found that it is not good, this is not the exact method, then you have to revise. Why? Because we have to give exact practical solution. Fine. So here you can see that this is a compressive testing machine. In that you have to measure strength of a shear strength. You can measure over here. You can test your like compressive test. You can measure tensile stress, tensile strength. Okay. So here in that I just wanted to discuss with you from the graph. Maybe that colorful picture will not reveal what is that, but yes, you just focus over here so you can understand what in a 3 days. Okay, the 3 days, 7 days, 28 days, 56 days, 90 days, 120 days, 150 days, 180 days means you can see that till 6 months we have just checked all the strength and all the things. So that first blue line, this is your conventional concrete M20 grade. That like light green line, this is M40 grade conventional. This is a blue line M60 grade of concrete conventional, means 100% cement. But near that dark blue having a dark maroon. So this is your concrete containing 50% waste as a cement replacement. Okay. That purple line is there. This is your F40 grade of concrete having a waste in place of cement. Okay. And this is your like light orange line is there near that. Light blue, light orange line is there. This is your F60 grade of concrete having a 50% waste replacement with cement. Okay. So this is the designation of all the color that try to indicate. So here you can see at the 3 days, 3 days that not you can't see that much difference. But here in 7 days you can see the whatever concrete we manufacture using 50% waste as a cement replacement, having good compressive strength compared to conventional concrete at 7 days, at 20 days, at 56 days, 90 days, 120 days, 150 days, and 180 days. You can see that there isn't that much big difference. That much big difference. But here, what positivity we are considering? What positivity? That we are using waste material means we are using our cost. We are using waste means we are reducing the use of cement. So we are saving environment, strength is good, and that's why we are planning, we are thinking that in place of 100% cement, we can use 50% waste material to manufacture concrete because strength is a little more compared to 100% cement and properties are good. How we can say? Because there is a tensile strength test also there. So that round cylinder we prepared, that we put in that and we just measure the strength. Okay. So here also whatever designation I told you regarding M20, 40 and 60. So here also you observe, but here you just see concrete is always good in compression but weak in tension. Okay. So here you can see there is a good compressive strength for all grade of concrete in each and every time interval. Fine. Same way, flexural strength. I told you, you are sitting over here. Suddenly, earthquake is there. Suddenly, any sudden load will be there, or your beam, your slab that will deflect. Then you having a time to rescue yourself, right? So we have to do for flexural strength also. In that also, you are seeing a similar type of little increased result. So that we can conclude if with 100% cement we are polluting environment, then so CO2 emission will be there, cost increase will be there. So why should we not use that material? But because it's a waste saving environment and the cost reduction will be there. So why we should not that? So by using the material methodology, by testing the flexural strength, by achieving such result, we can conclude or we can guide somebody. This is the shear test. Why that we did shear? Because some beam column junction will be there, okay, or any load bearing structure is there. So in that case, what will be the shear effect? To check that, we did a shear check also, and in that case also we found our material good, okay. And here I just wanted to tell that our Indian method regarding shear check is found by my PhD research supervisor, Dr. C.D. Modhera sir, and his research supervisor from IIT Bombay, Dr. Bairagi sir. He written so many nice books. You can go through that to understand so many aspects of your mechanical field too, regarding plates, shells, and everything. So they investigated a method, whatever I have shown you the assembly. This method is investigated by my research supervisor, Dr. C.D. Modera, and his research supervisor, Dr. N.K. Bairagi sir. And N.K. Bairagi sir written so many good books in a field of mechanical engineering. So you can refer that. It will be beneficial to you. And there is another Japanese method. In a Japanese method, there is another assembly. So that assembly I didn't mention over here, but compared to Japanese method, our Indian method is easy to follow, easy to maintain, and we can get result easily. So we check that shear check from both the method, and we got good result for our waste replacement. So we can say that yes, steel industry waste is feasible for shear strength too, right? Impact strength, I told you regarding sudden impact will be there. So here you can see the assembly from certain height. We are throwing one heavy iron ball from that on that disc, and there is a crack will be there. So we can check the impact strength. For that, we also found good result for all the grade with the 50% cement replacement. Now NDT. Suppose I give confidence to any stakeholder. He's preparing that, okay. But afterwards, some people having doubt that ma'am is just doing her advertisement, and because of that, the people is utilizing material. But no, madam is telling lie, and that wall or that structure having not that much strength, okay. So we have good testing method. Non-destructive testing means I don't want to that do cube and I have to destroy the cube, and we have to do just non-destructive means the bound hammer test is there. Okay, ultrasonic pulse velocity test is there. By using that test, if my structure is already prepared, building is already prepared, and someone have doubt on me, so by using that gadgets, they can check the strength and they can say, no, madam was not telling lie. Exactly, that strength is there. So non-destructive testing is there. We no need to destruct our cube, our structure, and we have to measure the strength. There is some Indian standard is there for a powered hammer. Results are good. For ultrasonic pulse velocity, okay. This is for beam, column, wall. You can do such type of things without breaking your structure, and you can measure the strength. So in a non-destructive testing, also our results found okay. And we did ACM, scanning electronic microscopy. Fine, because sometimes what happened in a general way, again I will tell you, suppose your ma'am is looking very good and very genuine, but inside she is a very political type of ma'am. Okay, this is in our real world when we are interacting with each other. Okay, so concrete is like that. In appearance, in outside it is a look like a good, but what is inside? Okay, so ACM analysis is a such type of thing. So concrete appearance is good, aesthetic look is good, no issue from outside. But whenever we are going to inside, so here you just try to focus. Here I gave one number in black. Okay, so this is your cement matrix. Fine, your cement matrix means cement sand bonding. Here third number, this is like your cement particles. In second number, you can see big aggregate. In fourth number, you can see the bonding between that cement matrix and that aggregate. Okay, fourth number. This is fourth number. There is a bonding between aggregate and your that cement sand matrix. Okay. So from that SEM analysis, what we came to know that if your ITZ means interfacial transition zone, means the connection between your aggregate and your cement sand paste. So inside when we went through ACM analysis, scanning electron microscopy, So at that time, what we feel that its microstructure is a dense. Microstructure is dense, means having a good strength. Fine. Then for we went for that interfacial transition zone. Means is there any whatever cube was there? We did testing on that, and one small piece of particle we have taken, and in that we just measure the crack. Means this is the after destruction of cube. So you can you imagine this is only 18.30 micrometer. Okay. So after the destruction whole cube, we are just observing that much small crack, means concrete is quite good. Okay. In that case also we are just trying to convey cement metric is good after the destruction of that cube, means after tasting of cube generally concrete cube is like going to crush, but here only you can see 6.41 micrometer, 6.73 micrometer crack is there. Okay, this is for different grade. Here you can see micro crack in interfacial transition zone. So when that micro crack occurs after destruction of, this is not the picture when cube was there. To select that particle, we have to break the cube. Okay. So what we did compression test, and after compression test, when we found any particular object, particular part from that cube, that we selected for ACM analysis. So that was quite good. Okay. So from ACM analysis, we just try to convey it's a microstructure is really very good. But now again, look will come in picture. So this is a visual surface status comparison of conventional concrete to concrete having a 50% waste. Different exposure after 180 days, means we did salt exposure, means there is 100 liter of water will be there, and you have to add 10 kg of your salt. Okay, or you can use directly marine water. Then HCl exposure, MgSO4 exposure. So you can see when conventional concrete was there, so surface is not that much deteriorated in salt, but in HCl, in MgSO4, it is deteriorated. Means this is some you can see some change in color and some scaling. Okay, but here you can see not that much effect on surface. So we can use that waste in concrete production, likewise in 40 grade, likewise in 60 grade. Okay, so thing was that why we are confidently using steel industry waste, because all the material properties we checked, fine. It is found very good in each and every strength. We did replacement from 10 to 100, but what was the exit and good result? It is with 50% replacement. So with 50% replacement, we check all the strength parameter, most of the durability parameter, and there are few also there are so many things we checked and everything, but due to time limit, I didn't mention over here. But if anyone is really interested in that, this work really can be extended in a good manner, good way for exactly practical point of view, so that person can directly contact to me. So I can share so many good and so many advantages and advanced thing with that. Simply, we can say that steel industry waste, this is a best for construction industry in concrete manufacturing with 50% replacement, right? So what is the conclusion from our that topic, our that particular session, from the observed result, whatever things we discussed? So as per workability aspect, whenever concrete construction industry and concrete is coming in picture, so yes, we can easily work with concrete. Strength is good. It is durable, means in any aggressive environment, it can be sustained. So it is durable also, sustainable also. Economical means if a cement bag having 50 kg cement bag having price cost of 250 to 350. Okay, 250 to 350. I always tell French because it's vary. And if we are using that material, then its cost will be like 170 to 200. So there is a simple cost reduction. Now, from that, exactly from that steel industry waste, utilization in construction industry as a concrete manufacturing. What is the recommendation from outcome, right? So we can say that it's recommended to use a C20W50, means 20 grade of concrete having a 50% waste replacement in concrete mix for low rise construction work considering nominal mix as per IS 456 2000. Yes, I can say from this research, from this discussion with confidence, I can say yes, you can use that waste for low rise construction. From the investigated fresh and hardened parameter considering durability result for 40°, we can say that this mix reveals the higher performance of this concrete in severe exposure and maintain strength aspect too. Therefore, it is suggested to use proposed, means whatever we introduced concrete mix that we can use for beam column work, for high-rise building, for RCC work, for foundation work, and in mass structure too. Better workability with good flow, higher strength, higher durability, dense microstructure of 60 grade or concrete having a 50% waste, introducing the concrete type as a high strength concrete too. This type of high strength performance concrete is suggested to use in marine structure, bridge, pier, and high rise structure too. Right? What is the contribution from this research? No doubt we discussed the session and everything, but whatever we discussed, this is the actually practically implemented thing. Okay, whatever we did, whatever we discussed, so what was the contribution? Okay, I told you, there are so many salient features in that particular topic, but due to time limit, we are not discussing, but exactly what research contribution. We gave proposed relations to civil field, that the proposed relation between experimental evaluated compressive strength and strength we predict from artificial neural network to why, because we have to deal with around 10,000 of specimen. Okay, we have to deal with around 10,000 of specimen. The person having a little awareness about the concrete, so they can understand in a concrete field what will be the that number means. Fine, whenever any mechanical, any EC computer people are doing some simulation, like it is like we did 10 lakh simulation, 20 lakh simulation. Okay, so this is a good number for them. So in a civil field, in a construction concrete field, 10,000 around specimen is like the specimen. From that you can make your own home. Okay, your own residential home you can prepare. This huge quantity of concrete we prepared for research work, and based on that, with confidence we can see. So these are the relations, equations we have given to civil field from this research. Okay. These are the, I didn't discuss that part during our session, so I'm not going in depth. But if any people is interested to know about that in detail, please write me email, okay? Because what I'm thinking, sometimes what happened, what you try to convey to me, maybe I not exactly give you that answer, and you are not satisfied, and you have to just close your question over here. So that is a means I'm not feeling good. If you have any doubt, any query, really you are interested to know, then please write me email. You can WhatsApp me. It will be very fruitful and good discussion, that what exactly solution, what exactly discussion you want, what exactly idea you want. So I will be very happy if any people is interested in that, and he or she will contact me for this. Okay, so we can say that the steel industry waste is really very good, and very good. Why? Because we can easily do waste management, waste disposal problem can be solved out, and mainly that we can solve the problem for construction concrete industry, because only construction industry itself, it is responsible for too much environment problem. Okay, it is responsible for that. And here whatever I just try to convey, that 10,000 number of specimen and all the things, because here I will reveal few names. I am not revealing any party, any person's name, but here this is the really proud moment for me. That's why I am revealing that for this research work, Department of Science and Technology, Guj Coast, Government of India. They financed me like a 3 lakh rupees grant for this work. Okay. But whenever as a girl, I am going to conduct this research work because concrete is a little bit difficult to manage. That much data, that much work, laborious work, whatever images, whatever things you see, this is every discussion from my own experience, my own work. Okay, so nothing from Google. Okay, so I just wanted to tell you that Ultratech cement, you hear the name Ultratech cement, good plant in Surat Hazira. So they then SR Steel Hazira, Ultratech cement, and so many industry persons who are dealing with that, they all provided me free hand help. Means whatever shade they provided me to handle that much amount of concrete. Okay, that much amount of concrete. This is a huge quantity. Means you can prepare your own home. So in a that much, if you are preparing your own home, having a good 2 to 3 bedroom hall, kitchen room. So whatever concrete is going to spend in that much concrete we prepared for prototype. Okay, so they given free help of labor, then worker, and they helped me a lot. Ultratech Cement, SR Steel, Hazira, and SVNIT. So I am acknowledging them. They helped a lot. And I think whatever I want to convey to you in that session, I completed. Some important part is that I didn't include. But if any person is interested, that person can email me, that can call me, that person can WhatsApp me. I will not respond immediate, but definitely I will respond your query. So thank you so much. And my end statement, we are surrounding by environment only. To save environment, it is our priority. So as an academician, as educated people, as an industry academic people, how we can do waste management from our surrounding and give better solution to industry, that will be helpful to us. So my just line, stay safe, take care, all the very best, save environment, and if any question is there, you can ask me. Thank you so much. Yes, sir. Hello.
Ma'am, again, I thank you for again a wonderful presentation, and I found few questions from the participants, which I would like
Yes.
to ask you.
Yes.
It's through the depletion of sand basins, a threat to construction industry,
Yes.
and escalating the cost. Is there any
Mhm.
research that is going to recover sand from construction waste and
And hello.
is there any techno-commercial alternative to the sand? This was asked by Mr. Gurulingam. Thank you, ma'am.
Yes, yes, sir. I heard half question only. Please, will you repeat?
Yeah, please.
Yes.
Okay, ma'am. Again, I'm repeating.
Yes.
Sir, probably I can repeat the question. I can ask the question to ma'am.
Yes, sir. Yes, sir.
The
Please,
second
please.
part of the question is there any
Yes.
research that is going on to recover sand from the construction waste? Fine, 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 sir.
Yes, sir. Yes. Sir, very nice question. Thank you for this fruitful question so audience can understand. There are so many research going on for sand also. It is a manufactured sand. Okay, manufactured sand. So many research is going on from construction demolition waste. Yesterday in ceramic, that waste, I just used some lines from that. Whatever construction demolition waste is there, so that we have to collect, and by contacting that crushing, there is some recycled aggregate crushing machine also. So in that machine, we can use that construction demolition waste to gain in a way of 10 mm size, 20 mm size, or in a sand size. So yes, construction demolition waste can be used as a sand replacement, as an aggregate replacement. We can use, and manufacturers sand is a trendy topic nowadays to give solution to natural sand. Hello. Hello.
Yes, ma'am. Thank you, madam. The next question is, can the scrap of steel in the form of chips and
Yes.
end discards be used in precast RCC blocks and road laying? Is there
Yes.
anything in this direction being happening? That is there any research going on this particular field? Thank
Yes,
you.
this is the right now. Yes, sir. This is right now the trend that directly that steel scrap or steel chip. This is the using in a precast concrete also. Even in Gujarat, at so many places, this practice is going on. Fine, but this practice is going on. But what we are expecting that from that steel scrap or steel chip we can directly use. Okay, but after so many years, we have to consider durability point of view, because whenever any steel part will become in the contact with concrete, so after so many years there will be a problem of corrosion type of things. Okay, people in a field they are using that steel chips, steel scrap in precast and so many other concrete production too, but after so many years, after many years, there is a problem of corrosion and everything. So to avoid such problems, that is steel scrap, steel industry waste, steel chips we are using in construction work as a sand, as a cement to overcome the problem of corrosion. Yes, sir. Hello. Hello.
Yeah. Next question, ma'am. As per yeah, you can hear me, ma'am. Yeah.
Yes, yes.
Hello. Yeah,
Yes, sir, yes.
ma'am. Yeah. As per regulation, as per
Yes.
regulations and specified standards, are there those recovered cement grades acceptable, and what are the safety norms stipulated for using recovered grades of cement? Is construction
Excellent.
industry
Okay.
adopting this alternative, and
Okay.
the
Okay.
present status? Thank you.
Okay, 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 fine, fine. A very good question. Actually, in my lecture, I just mentioned, but maybe I don't know you understood at that time or not. Indian standard give us guideline for M20 grade. Okay, M20 grade, and Indian standard. There are so many standards. British standard is there, American standard is there, Japanese standard is there. But by focusing on our Indian scenario, I am just taking about only one standard, but it will be applicable to all. Okay. So in India, what happened? We are having our Indian standard for different material and everything. Whenever we are considering for cement, okay. So for cement, we have standard. For concrete manufacturing, we have standard. Okay. Generally, which cement we are using? OPC 53 grade using, OPC 43 grade using. Okay. So for that, we have standard. We are going for a strength calculation, other characteristic calculation by using that standard. For concrete manufacturing, M20 grade concrete mix design data we have in our Indian standard guideline, and in many standard like it's American, British. So yes, some regulatory guideline is there for material selection, characteristic, strength. But whenever we are going to use any waste material, okay, any waste material, so to utilize waste material, some guideline is there that we have to use in a that much proportion, like I just use like 3 to 30, 4 to 14, 5 to 10. So some type of drafting guideline we have, but this is not exactly solution that yes, for M20 grade concrete, so you have to use only that much proportion. To use to prepare M40 grade of concrete by utilizing waste, you have to use that proportion. That exactly fixed regulatory guideline we don't have in any standard. Okay, whatever work I have discussed in this session, so from that, yes, we can give some regulatory guideline. Yes, you can use that waste in that much proportion. This is the guideline from that session. But again, there is a limitation. Why limitation? Because this is suitable for Gujarat. Okay, by considering the weathering condition, soil property. As per soil property, there will be a difference in characteristic of that waste. So we can say whatever section I discussed over here. So maybe that will be acceptable in Gujarat only. That test result, that material selection, its proportion selection, its strength outcome, durability outcome. So at the summary, we can say we have exactly rules, regulation, guideline for exactly conventional concrete M20 grade, conventional concrete, steel M20 grade, cement for OP353, for OPC 43. But whatever waste you are using, for that we don't have clear that much guideline, and that's why in India people are fearing to use such type of waste for construction work. But if I am not wrong, in Satyabama University, when I attended one conference at that time, one CSIR scientist came, and during my presentation, he told that he used that material, I think 3 to 4 decades ago, and that structure is still there. Means they used that material, whatever I introduced, before 40 to 50 years, and that small structure is still existing. And sir also that he also agreed, work is nice, work is good, concept is good, but people are fearing to adopt it. Why? Because we don't have that much fixed, perfect, and confident guideline. Okay, even myself, I did that work. I am having confidence. I can prepare my home with that material. Okay. But if I will tell you I did that instead work, please use that material, make your home, save your cost, save environment. You are not going to do that. Okay. And for that, what required? Exactly, perfectly clear Indian standard or any perfectly guideline, and the guidelines should be forward to municipal corporation, government officials, stakeholders, that you follow guideline and use that material. Okay. Yes, sir.
Yeah,
Hello.
next question. Yeah, yes, ma'am. One question audience directly wants to ask you, Dr. Kakkade Genudas Nivritti. Sir, you can, I have unmuted you. You can ask the question directly to the resource person.
Yes.
Dr. Kakkade? Dr. Kakkade, you can talk. I'm unmuted you. You can ask the question. Hello.
Yes, sir.
Yeah, seems taking time.
Hello.
Yeah. Okay. It seems it's not completing the process. It seems.
Okay.
Hello.
Yes, sir.
Yeah. Yeah. One question I wanted to ask, of course, from the chat itself. Like one, it is an interesting question. For all the research work you have done, why have you not patented it?
I actually now, frankly speaking, that I was not that much aware about my initial stage. Okay, I was not that much aware, and I am having the thing that I want to publish paper. So I made a very big mistake that I published a paper. If you once you publish paper, you can't do patent on that work. Okay. But my some unrevealed part is there, which I didn't discuss with you guys also. This is my monopoly. Don't take me wrong because I want to patent it. Okay. If I will put over here, then I have to give to organizer and they will give to you. And again, that will spread and my patent will not succeed. Okay. So whatever interesting part I can discuss with you later on. But yes, my some specific part is there, which is a very key point of research. For that, I am going for patent. And one another collaborative work with what I did with the computer, mechanical, electrical EC people. That my one patent published just last month. My one patent published last month regarding smart city concept. And regarding my that research work, I published so many papers. So as per rule, if you published a paper and so many years passed, so you can't do patent. But yes, my few research work is there, which I didn't publish any paper regarding that, and this is the silent feature. So on that, I am working to draft patent, and definitely I'll do it. And I am just planning. My planning are so many big planning, but also I am also finding a good people to support, because whenever you want to go far, you need a good team. So you can say that this is my just beginning after my PhD. So I am finding good persons who can come with me as a team, and I can do some good work for our society, our engineering field. Yes, sir.
Thank you, ma'am, for a wonderful session which which you have been presenting for past couple of days. All your sessions have been very, very interactive, and very most important thing here is they are very practical oriented.
Yes,
We were
sir.
used to we have been used to seeing very theoretical analysis, but you have been presenting them in a very practical manner. You yourself have gone to visit sites and analyzed so many things and found out issues and tried to solve them. So, ma'am,
Yes.
very much. On behalf of Department of Mechanical Engineering, we like to thank you for being here being the presenter for the past couple of days, and taking time out from your busy schedule, and I've been delivering the lecture in a very clear and easy to understand manner. That is the very important part, and we have been receiving a very wonderful feedback from the
Yes.
participants regarding your sessions, madam. Thank you very
Thank
much,
you.
ma'am, for being here,
Thank you. Thank you,
and
sir, that
we'll
much.
definitely.
Yes, sir. Sir, thank you so much for nice words. And this is my warm welcome to all the participants, and even sir, your institute and all the organizers, all the speakers, experts, that if anyone interested to do any collaborative work regarding this particular field, then you all are most welcome to discuss with me, to share with me whatever help I can do from my end. Definitely, I will do that help. And with the collaborative as a teamwork, we can achieve so many good things. So if anyone interested for any type of research work collaborative in that field, that person can contact me. My phone number, email ID, everything is given. Thank you so much for such nice feedback and giving me opportunity to be a resource person. So I'm really thankful to organizer, institute, Atal FTP, AICT, and all the participants, speaker, and experts. Thank you so much.
Thank
Thank
you,
you, ma'am.
ma'am. On behalf of organizing team, we thank you so much for coming forward and presenting in 3 sessions. And it was, I mean, all the 3 were excellent, and it was eye opener to all of them. Thank you, ma'am. Thank you from the bottom of our heart. Thank you so much.
Thank you.